So this is the notes for 1.2. I'm actually going to break this into two different videos. So the first part will be about the ruler postulate and finding the length of segments or the distance of them. And then the second part will be the segment addition postulate. And if you want to, when video 1 is done, if you want to go on to Big Ideas Math and do the first probably 10 problems that deal with the examples that I do, then make sure you save it and then go watch the second video to break it up a little bit if you need to. That'd be a good idea. So section 2 is all about measuring segments and finding the length of them. So one of the things that you have to do is the ruler postulate. So most people, when you take a ruler, a lot of people like to start at 0, but you don't necessarily have to do that. So that's kind of what it's going to talk about, is matching up points. So if you think about it, anytime you have a line or you're trying to find the distance from one point to the other, you can correspond it to a coordinate. So in algebra, we typically think of these as our number line. It can be a ruler, it can be whatever it happens to be. So if we think of a typical number line, if I assigned point A to -1 and point B to 2, I could easily count and find the length of this. Or I can think about it as the distance, and distance is always positive, so it's the absolute value of the difference of two different points. So I could count 1, 2, 3, or I could find the absolute value from 2 to -1 is the absolute value of 3, which is still 3. So anytime you find the distance, you're actually finding the length of a segment. In this case, AB. So instead of having to write out the length of segment AB, we could just say AB, and notice I didn't put a symbol above it because I'm not talking about the segment, now I'm talking about the length of it. Length of it is an actual numerical value. Okay. Also, when talking about this, when we say two segments have the same length, then we know those segments are equal. So here is an equal sign is equal to versus a congruency sign, which is saying we know the lengths are equal. It can get a little confusing, but just for this unit, until we get further into it, just know if something has the same length or the distance between two things, those segments are also congruent. So if we do some examples of these, so we're going to talk about the ruler postulate a little bit. So here's an example of that ruler postulate. So they already have a ruler on here. We notice this one is in inches. So we know that A is at 2 and B is at 5 1/4. So if I wanted to actually find this, I would find the absolute value of 2 minus 5 1/4. And I could find the length of it. What they wanted to do is somewhere over here, they made an error. So they want you to recognize that A is at 2, it's not at 1, but we could still find the length of this. And remember the absolute value of this. So this would be 3 1/4 instead of the 4.25. Okay. On Big Ideas Math, they are going to have you measure things. So there's a little ruler that'll pop up. So you can move that ruler wherever it is. So if you wanted to start it at 0 and make your life really easy, you could. Oops, this one, they want it in centimeters, so I need to switch this over. So I could easily lay this down and find out that this is 2.5 centimeters. And they'll give you a little margin of error on that, so get pretty close. This one, if I wanted to use a ruler postulate, so I'm going to say that I'm going to start this at 5. And this other part is ending up at 10.7. So if I wanted to find the length of this, I could find the difference of these, which is the difference of -5.7, which is 5.7 centimeters. Okay. The other way they'll use this is to tie it into your algebra skills by using a coordinate plane. So if you have problems like this, the first thing that I want to review is, remember, you have an x-axis and a y-axis. And where they meet is the origin. So remember, anytime you have a coordinate, there is an x-coordinate and a y-coordinate. So let's plot these points. So -5, 5 would be A. B is at -2, 5. So if I wanted to find the length of this, obviously I could count, but if I want to use that ruler postulate, notice my y values are the same. So I'm really finding the difference in my x values. So -5 minus -2 gives me the absolute value of -3, which is 3. And I could do the same thing with my y, C and D. So if I plot C would be at 2, -4. And D is at -1, -4. So here again, I could count and go, this is 3 away, but let's use our ruler postulate. So here again, I'm finding the difference of my x's. So 2 minus a -1, which is the absolute value of a +3, which is 3 away from 0. So if I know the length of AB is equal to the length of CD, then I know segment AB is congruent to segment CD. Okay. Let's do one more of these. So A is at 4, 0. B is at 4, 3. So if I find the length from A to B, this time our x's are the same, so I really just need to find the difference of my y. So 0 minus 3. So the absolute value of -3 is 3. And for C to D, so -4, -4. And D is at -4, 1. So even just by looking at those, but to prove it, we need to find the length of it. So here again, I'm going to find the difference of my y values. So -4 minus 1 is the absolute value of -5, which is 5. So the length of AB is not equal to the length of CD, so they are also not congruent. Okay, this is probably a good thing. I will put example 3 in my completed notes when I post those, but I think those would be some good examples for you to do. This is a good place after this video if you want to go on to Big Ideas of Math, like I said, and do the first 8 or 10 problems that match up with these. Before you watch video 2 is fine. Just make sure that you save your work.